It's my pleasure here to be presenting the reputation system for persons and IoT devices. So briefly, this talk that we are sharing will provide a brief introduction to reputation, to some related terms like trustworthy. Then we will give a deep dive into the role of the reputation system in the Arcadian IoT framework. We will provide some information regarding the models, so the mathematical foundations that allow us to determine a score, which we consider as the reputation score. The architecture that we have conceived, designed either to collect data, also to do the processing of this data, and at the end do the formulation of the score. The connection between policies and reputation, as we saw in the previous talk, it is very relevant for the network authorization. So, in the first point, what is the reputation? So, if we look for a dictionary definition, it's somehow the opinion that people have about something or someone. And this opinion normally is based on information on some events that might have occurred in the past. So it's in a first instance, it's always complicated to have an opinion of someone or something that we don't know. So we, at the end, we can have, let's say, good or bad reputation. And this concept is, let's say, varies too much. So it's very volatile because in face of some events, we might be happy with a person, but on another's, we might not be happy. Some related terms that appear so related with reputation are trust and trustworthiness. So there are, let's say, we could talk about this with more detail, but just trying to provide here some clarifications. So trustworthiness, we can see it as the worthiness of a system being or a service being trusted. And for the trustworthiness, we rely on this worthiness, so based on evidences, so based on information, objective information. But in somehow it can also be very subjective. Why? Because how we measure the level of trust, it will differ between different persons. The trust, it's more related, let's say, with the reliance of a system, of a service, that it will behave according to an expected behavior. These concepts, trust, trustworthiness, reputation, are widely used in different domains. And we are also used to see the reputation in different platforms. So, for instance, either doing acquisitions in platforms like Amazon or Google Play, we always look, let's say, to the stars, to the rating that is present for a specific item, so that we can have, let's say, an opinion from others if a product has a good quality or not. So reputation already affects our behaviors in terms of how we buy, how we sell things, and how we interact with others. So, and this was already also presented. So reputation is part, let's say, of the trust vertical plane, and it is relevant to allow to determine how the trustworthiness of a specific entity, being this entity a service, a device, or even a person. And the reputation system has also connected different policies, either for a network authorization, but also, for instance, for the base station. And we will see later on that these policies can be configured according to a different score that is formulated. So at the end, the objective and the major purpose of the reputation system is to determine the reputation. So to provide here the level of trustworthiness that we can have in a entity, so in the entities that are supported in the Arcadian IoT. So mainly persons, devices, and applications or services. And the question that we might ask is how, so which information is relevant, so how we determine the reputation. And on this regard, we can leverage on the information that is shared by other components from other lanes, so from the Arcadian IoT, as well as from the services components of the domain owners. Giving here's just very simple examples. So when, for instance, an entity is registered, as we saw using the deeds, this information is used mainly for the reputation system to be aware that we have a new entity and that we need to initialize the values of this entity. And this initialization is made knowing that an entity, there is a new entity, and let's say this entity, the initial value of the reputation, for instance, is neither trustworthy, neither, let's say, so we do not have yet an opinion formed. So it is a value that is set for the middle of the scale, which, and the reputation score varies between 0 and the value 1. And according then to other events that can occur, this value will differ. And for instance, some examples, we can have information from the multi-factor authentication. So for instance, if the authentication result is successful or not, this can be used to increment or decrement the reputation. For instance, in the self-recovery, so if an entity is recovering well or successfully, then this information can also be used to increment the reputation, or for instance, using specific information from domains that, for instance, considering drones, if they have completed successful a mission, then we can increment the reputation of a drone, or from other domains, for instance, in critical infrastructures. If a device is able to send data, then this event can also be considered for the reputation. Of course, we have information, but how we can, let's say, use this information to obtain a score. And for that, we rely on different mathematical models, and some of them have, let's say, are only applicable to certain types of entities because they have also some requirements. So what we use is the alpha beta, mainly for all the types of entities. And in ARCADIAN-IoT, we also came with alpha beta adding severity information, because some components will provide information regarding the severity level of an event, and this could be triggered to impact how the reputation changes. And the dominance model that is mainly suited for persons gathers information from, let's say, different persons regarding a specific entity. So, entering in detail of the alpha beta. The alpha beta, this model mainly considers, let's say, two types of events, so either positive or negative. And these events, let's say, so the positive will contribute positively, let's say, to the trustworthiness of an entity, while the negatives, they contribute negatively. So they will lead to reducing the reputation. Then we have here a formula that considers mainly the information of the events that we receive, but I just want to end the type of events that we receive, being alpha the positive and the beta negatives. And we have also here an aging factor. This aging factor is mainly for us to have a kind of a window considering the events that we receive over time. And if we have a higher aging factor, this means that our window will consider more events for the change of the reputation. The, the alpha beta with severity, mainly, let's say we are having mainly the severity information so that we can, let's say, influence the score of the reputation more, let's say, more rapidly according to the severity level. Here we have considered a simple scale, so severity varying in 3 levels to avoid fuzziness, because these scales normally can also be very subjective. That's why we opted to use a simple scale, so only with these 3 distinct values. On the other side, the dominance model. This model, I'm not here providing mathematical formulas, but the main idea is that we are able to aggregate the information from different users regarding a specific entity. And this aggregation will then allow us to have a score, so the reputation score. And the formulas that are used is also includes some, let's say, some protections mainly to avoid user bias. That is, if a user is always giving, let's say, a bad reputation to an entity that is providing evidences that it has a good behavior, so it should be a reputable entity, that the user is not has no means to affect the reputation on an opposite side. Nonetheless, since these require feedback from users, this means that we can only apply this type of model when we have the feedback provided by users regarding a specific service. We have implemented, let's say, so we saw already the information that we can use to determine the reputation score, the mathematical models that we can use, let's say, to give us a score in a specific range. Then we now enter more in the building blocks that allow us to collect all this information and of course, to determine a reputation. So on this regard, we have mainly, let's say, 2 major blocks. So one for the policy management. So specifying the policies that can be used either for the network authorization or for the attestation, and how they relate with the reputation scores. And then we have the reputation management, which is mainly responsible to collect the data and to determine a reputation according to the implemented reputation models. So on this regard, the reputation system communicates with several components in the Arcadian IoT framework. And given that we need to communicate with several components, we have also concerns regarding scalability so that we are able to process the events that we receive. So that's why we also have concerns with using technologies that allow us, for instance, to have databases in memory to accelerate the processing. On the other hand, the reputation system also shares these reputation scores through other components, mainly uh, so uh, through the permissioned blockchain. So sharing here to share the reputation updates of a given entity, um, and the reputation system also, when providing the updates regarding the reputation, also maps this the value, the actual value of the reputation score to the configured policies, so that other components that are responsible for the enforcement of such policies can know in a given moment which policy should be applied. So this picture provides, let's say, a very high level overview of the technologies that that have been used in the reputation system. For the policies, we have relied mainly, let's say, on Node.js and React because we have a front end where a user can specify the policies on the side of the reputation system, which was developed in Java. We have used Apache Spark mainly to facilitate us the pipelining of the data processing, NoSQL and SQL databases, um, and Redis for the in-memory databases, mainly for to facilitate, to allow us, let's say, a faster processing of the events. So this is mainly the information that I've shared. Since in Arcadian IoT, the reputation by itself has a meaning, yes, it expresses the trustworthy level that we can have in an entity in a given moment, but we also associate it with policies that can be used for the network authorization and for the attestation. And on this regard, we have developed a graphical interface with REST APIs that would allow to specify the the different fields of a policy. And we have here so some examples regarding the policies that can be used, for instance, for the authorization. And where we establish, for instance, the ranges of the reputation where that policy should be applicable, if it should affect either the traffic in uplink and downlink or only in uplink, and then let's say the type of action that should be applied, if it should deny or allow the communications, or even allowing with a certain bit rate, as it was explained by João in the previous talk. So on this regard, the reputation and the level of trustworthiness is or let's say present in the internet, and it's also affects our behavior, and in the Arcadian IoT, let's say it is also relevant for the chain of trust, because this component collects information that allow to determine the trustworthiness level of a specific component of an entity, and that's why it is a crucial component. Um, of course, it's always challenging to determine the reputation because the different models have also their drawbacks. So it's always challenging to determine objectively and the values of the reputation.